So here's a nice review problem for differential equations. This one looks like it's separable. So we've got dx dt, and then on the right side you could write that as x squared times t squared. And then move the x's to the left side, so divide both sides by x squared. Let's divide by x squared. And also multiply by dt. So then after you cancel, the right side just has t squared dt. And for the left side, I'm going to rewrite it as x to a negative 2 dx. And then integrate both sides. So on the left side, add 1 to the exponent. That's going to be x to the negative 1 divided by negative 1. On the right side, it will become t cubed over 3 plus a constant. And there's also this information that when you plug in t equals 1, then x is going to equal 1. So if you substitute a 1 for each of them, you know what, on the left side, I think I'm going to rewrite it as negative 1 over x. I prefer to not use negative exponents. Okay, so now if you substitute a 1 for t and a 1 for x, we can solve for c. So on the left side, that would be negative 1 divided by 1. And on the right side, that's going to be 1 cubed over 3. And then we can solve for c. So if you subtract 1/3 from both sides, then on the left side, that's going to be negative 4/3. So that is the C. So then I can put my answer in this box. Oh, wait. Actually, I still need to do algebra. So if I go back to this equation, I can substitute the C. I forgot that I hadn't solved for x yet. Uh-oh. And so substitute what c is equal to, negative 4/3. And on the right side, I can even combine those. And the reason is I'm going to need to invert, so I might as well just write the right side as one fraction. And now, two things. One is get rid of the negative, so multiply both sides by negative 1. And then we would have 1 over x equals, and when you multiply by a negative, you could say that the 4 becomes positive and the t cubed becomes negative. And then finally invert, so the left side becomes x. The right side becomes 3 over 4 minus t cubed. And then it's ready to be put in a box.